Alright, so in this equation, I have 1 to the power of x is equal to 3. So this might seem like an impossible equation, right? Because how can 1 be to the power of any number and equal to 3 if 1 to the power of even a million is still equal to 1? Well, let's try to solve this equation the way we would solve any other exponential equation. The first thing I would do is take the natural log or ln on both sides. So I get ln 1 to the power of x is equal to ln 3. Now, if I have something in the form ln a to the power of b, I can move this exponent b to the front, so this is going to equal b times ln a. In this case, I have ln 1 to the power of x, and I can move x to the front. So now I get x times ln 1 is equal to ln 3. And now if I divide both sides by ln 1, these two cancel out, and I get x is equal to ln 3 over ln 1. Now, if you guys already didn't know, ln 1 is equal to 0. So I get x is equal to ln 3 over 0, and you can't take any number and divide it by 0 because that's undefined, meaning this has no solution. So that method doesn't work. However, this just means that there are no real solutions. But there are different types of solutions. So what I'm going to do to solve this equation is, first, let's recall Euler's formula. And if you guys don't know what this is, it states that if I have something in the form e to the power of I times theta, this is equal to cos of theta plus I times sine of theta. And I know this may seem a little complicated right now, but just bear with me. So let's say that theta here is equal to 0. So if theta equals 0, then I get e to the power of I times 0 is equal to cos of 0 plus I times sine of 0. So then I get e to the power of 0 is equal to 1, cos of 0 is 1, plus sine of 0 is 0, and 0 times I is 0. So 1 plus 0. And e to the power of 0 is 1, so I get 1 is equal to 1 plus 0. Now, what if we say that theta is equal to 2k pi? K being a constant, so it could equal any number, 1, 2, or 3. So if I plug this in, I get e to the power of I times 2k pi is equal to cos of 2k pi plus I times sine of 2k pi. Now, what if k is equal to 1? What if our constant k is equal to 1? Then I get e to the power of I times 2 pi is equal to cosine of 2 pi plus I times sine of 2 pi. Now, cosine of 2 pi is 1, and sine of 2 pi is 0. So I get this is equal to 1. Now, if k is equal to 2, I would get cos of 4 pi plus I of sine 4 pi. Cos of 4 pi is 1, and I times sine of 4 pi is again 0. And if I do the same thing with 3, I would again get 1 plus 0. So this pattern continues, and it keeps on equaling 1 no matter what value of k we get. So we can say that e to the power of I times 2k pi, this is equal to 1 no matter what value of k we have. So now this means that we can substitute this in back to our original equation, which is 1 to the power of x is equal to 3. This is our original equation, and we can substitute in 1 for e to the power of I times 2k pi. So now I get e to the power of I times 2k pi to the power of x is equal to 3, and this is my new equation. So now to solve this, I'm going to do what I did at the start. I'm going to take the natural log or ln on both sides. So I get ln e to the power of I times 2k pi to the power of x is equal to ln of 3. Now, if I have something in the form ln a to the power of b, I can move this exponent b to the front, so I get b times ln a. In this case, I can move x to the front, so I get x times ln e to the power of I times 2k pi is equal to ln 3. Now, I'm going to use this property again and move this to the front as well. So I get I times 2k pi times ln e is equal to ln 3. And ln e, these two cancel out. So now I'm left with I times 2k pi is equal to ln 3. Sorry, and I also have x. Now I'm going to divide both sides by I times 2k pi. So when these cancel out, and I get x is equal to ln 3 over I times 2k pi. Now I'm going to multiply this by I over I, which is the same thing as 1. So I get x is equal to I times ln 3 over I times I squared, and if you guys already know, I squared is equal to negative 1, so over negative 2k pi. And k in this case can't equal 0, because if k were 0, this wouldn't work. So this is my solution to this equation. Alright, so for this video, I'm going to be solving the equation x to the power of 4 is equal to negative 9. So what I'm first going to do is add 9 on both sides. So then these two cancel out, and I get x to the power of 4 plus 9 is equal to 0. Now from here, I can rewrite x to the power of 4 as x squared to the power of 2, and I can rewrite 9 as 3 squared. And if I have something in the form a plus b squared, this is equal to a squared plus b squared plus 2ab. And if I have something in the form a squared plus b squared, then this must mean that this is going to equal a plus b squared minus 2ab, because this is the same thing as this without the 2ab. So this means that a is equal to x squared and b is 3. Going back over here, so I get x squared to the power of 2 plus 3 squared is equal to x squared plus 3 squared. And this turns into x squared to the power of 2 plus 3 squared is equal to x squared plus 3 squared minus 2 times x squared times 3 is equal to 0. So now from here, I get x squared plus 3 squared minus 6x squared is equal to 0. And remember how the square root of 6 squared is equal to 6. So what I'm going to do is I'm going to rewrite this as x squared plus 3 squared minus the square root of 6x squared is equal to 0. And the reason I did that is because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So in this case, this turns into x squared plus 3 plus the square root of 6x times x squared plus 3 minus the square root of 6x is equal to 0. So this gives me two equations. I have x squared plus 3 plus the square root of 6x is equal to 0, and x squared plus 3 minus the square root of 6x equals 0. So for both of these, because both of these are quadratic equations, you can use the quadratic formula to solve them. So by using the quadratic formula, I'm actually not going to do that in the video, but you can try that yourself. You should get that x is equal to the square root of 6 times negative 1 plus I over 2, and x is also equal to the square root of 6 times negative 1 minus I over 2. And also, along with this, you should get x is equal to the square root of 6 times I plus 1 over 2, and x is equal to the square root of 6 times times 1 minus I over 2. So these are your four solutions.